Hi all. In this video, we present a paper titled "Deformable Part Model Can Be Represented as a Convolutional Neural Network." As name implies, this paper targeted or aimed to represent the standard deformable part model for object detections can be formulated as an equivalent convolutional neural network. For that, it has mainly the three steps. One is the standard deformable part model utilize uh, algorithm called histogram of oriented gradient for computing the input features. But here, to represent the DPM as a CNN, in this formulation called DPVM CNN, they utilize a standard CNN, similar setup similar to AlexNet to compute those input features and completely bypassing this algorithm system of oriented gradient. That's the first step. The second step, as usual in the same setup like in the traditional DPM model, they use multiple scales of images and try to have a pyramid of images as to compute those pyramid of feature input using the AlexNet, a single architecture AlexNet which share weight across all these scales. The third one is the DPM algorithm itself. So in the DPM formalism, an object category can be viewed in different appearance. So each appearance or each thing can be considered to be as a component of that particular object categories. So for the set of mixture of those components, and each component can be represented or in turn in each component there is a particular setup. One is low resolution global root filter, and another is each and the assumption one of the important formulation of the DPM is each object category can be represented as a star-like graph models. One is the center hub model, which connects each part of the each part. Each object is made up of a different part. That parts of that objects are connected by a center hub, that is a root filter, and each part can be resolved by a particular high resolution part filters. So during the test time, we try to it is something like a sliding window approach, and try to find identify those utilizing it to compute the hog future for each part, and it assigns a score based on the sliding window approach, and try to identify the score functions for each part and global part, and try to finally like kind of a max pooling, they try to identify a final score based on which is a promising direction, like a maximum score they computed efficiently using certain kind of an algorithms. So this involves a hierarchical steps. If we unroll those hierarchical steps, it can be ended up in a deep network with a fixed size. So that's what they have formulated as a DPM CNN architecture, which is overall highly represented in figure 1. So we have a pyramid of images from level 1 to 11 with different scales that is given into a standard convolutional neural network, like 5 layers. After the layer 5, it has a different, and the layer output of that considered to be as a features similar to that we have hog features at different levels. That all these features at different levels for that particular component is given into DPM CNN. Then we get an output of different score levels that would be trained to analyze what object, whether it belongs to that or not belongs to. So if we zoom again into that particular DPM CNN for a single component, the output of that convolutional neural network will be given into different filters. Then that filters will be going similar like our max pooling, which is a generalized version of the max pooling called distance transform pooling. Then output of those poolings are stacked together to formulate as a stacked map. Then that will be taken into a specialized filter. Then the output of the filter will be given as a final score values for a particular level and for a particular component. So if you go for a multi-component, this will be for the level 1. So this particular level will be given into multiple components, and that will be the output will be for the particular level from the different components, that output score level after object filter and DT pooling. Then again the maximum values are which part has to be more focused to represent that particular category can be taken out using this max operator, and that value will be taken out for the particular level. Now all those levels are concatenated together for further classification. These are the overall idea about this DPM CNN, and they compared this architecture on different data sets with different models, like traditional DPM model which uses hop features, and also the latest introduced at that time RCNN. And they claim that this seems to be performing a bit better than RCNN. Hopefully in the next video we'll see about the architecture about RCNN. Thank you.